I think I barely had time to finish this last one. So, what happens to the relative humidity of an air particle at the lifting um, condensation level? So, the relative humidity increases to 100%, and the air particle is saturated. All right, so let's keep moving. Um, now we're actually talking about rain or snow or ice. You know, actual precipitation. Okay, so each step towards precipitation is part of the collision and co- um, coalition process. So you need to have for precipitation to take place. You usually have to have some kind of dust particle. It could be pollen. It could be smoke. So some little dust particle. And condensation needs some kind of nucleus for the condensation to take place. All right. So and then you have these updrafts of air that is basically preventing the precipitation from falling. And so what happens is you get these little droplets, and over as they fall, they get pushed back up because they're really light, and it doesn't take much to have them push back up. But when they get pushed back up, they collide. So there's overall collisions that cause these things to eventually become large enough to be true raindrops. Right. And so, how large do they have to be? They have to be large enough so that gravity will pull will cause these things to fall and overcome the updrafts. All right. So once they weigh enough to overcome the updrafts, they begin to fall. Not necessarily. Mostly, the precipitation, by the way, in the upper atmosphere does not occur as actual liquid. It's usually frozen. Anyhow, the vertical development of clouds is necessary so that the droplet collisions occur. You got to have clouds to have rain. All right. Let's see. Raindrops sink as they fall, and because evaporation rate it can exceed the condensation rate once it leaves the cloud. If enough evaporation occurs, the raindrop will disappear before it reaches the ground, and meteorologists have a term for that. It's called virga. All right, so it's raining, but it's only raining in the sky. The rain doesn't actually reach the ground. All right, and that happens a lot actually. And of course, that's not really good for farmers. You want the rain to hit the ground. All right. So, and now, okay. So before we were talking about parcels of air. So now we're talking about entire air masses. So this is a huge amount of air, and so we classify these things. There's six different ones. It's just six different types of air masses. And so the capital A stands for if it's an Arctic air mass. The P stands for polar air mass, and the T stands for tropical. And each of those are broken down into where the air mass is. If it's over in water, it's called M for maritime. The C stands for continental. And notice the M is lowercase. So M capital A is maritime Arctic. It's supposed to be a capital P, by the way. M capital P is maritime polar. All right, so M capital T would be maritime tropical, or lowercase c capital T continental tropical. All right, and so here are some characteristics. It's definitely good to note that. So if you have maritime Arctic, you have cool, moist, unstable air. These are the tendencies. Okay, continental Arctic, cool, dry, stable air. Maritime, polar, cool, moist, but unstable. Right, and then continental polar, cool, dry, stable. Continental tropical. I'm sorry, maritime tropical, warm, moist, and usually unstable. And continental tropical, dry, hot, dry, stable, high up in the atmosphere, and unstable close to the surface. All right. So, and they show you the different places that these happen. That's what this picture is showing you, right? There's maritime tropical down here. The continental tropical is pretty much over the continental United States. Maritime polar, in the Atlantic and in the Pacific. Maritime Arctic up by Alaska, and maritime continental polar is mostly above Canada, and Greenland. And that's just the Western hemisphere of the world. All right. So now we come to what's called atmospheric lifting, the lifting of air. Okay, so we have there's three types of ways that air can be lifted. The normal is what is called convectional lifting. That's the normal thing that happens with you had hot air rising, and so that's convectional lifting, and so that forms cumulus clouds. All right, just keep that in mind. Orographic, it has to do with the shape of the land that the air encounters, and that can cause what are called rain shadows. We'll see that in just a moment. And then frontal lifting. So when these huge air masses encounter each other, you can have like you have fronts, like a cold front or a warm front. These huge air masses encounter each other. In those cases, you get cirrus clouds changing to cumulonimbus clouds. Okay, so there's usually some bad weather coming with these. All right, so this is just the normal lifting that we encounter. Convectional lifting, and there are some cumulus clouds. These are, of course, the puffy cotton-looking ones. They look, like big pieces of cotton. All right. Orographic lifting has to do with, there's some geological feature, some land, and that causes the air to lift. Due to the presence of a mountain or a hill or something like that. All right, so and then of course there's frontal lifting. So when a cold, so let's say you have this is called a cold front when the warm air rises very rapidly, and so when that happens, you get these cumulonimbus clouds. And then above that, there's some cirrus clouds. But notice you're going to have some rough weather, some thunder clouds coming in. So that's when the warm air rises very, very rapidly. All right, so that's called a cold front. For a warm front, the air it's going it's rising much more. So the warm air is rising, but in a much more stable condition. So it's rising gently, right? It rises, not at such a great angle like it did here. This one, it's rising very, very rapidly. It's this is usually unstable air rising. So this one, very, very stable air rising up. And so notice what's happening. You'll have nimbostratus clouds and rain, stratus clouds, and altostratus, which is the middle ones, and cirrostratus clouds. All right. All right, so that's called a warm front. All right. An occluded front is when a warm front and a cold front merge. So here, let's see. A cyclone. So, oops. Well, let's see. Is there more information we can get from this? So yeah, it's just when the cold front and the warm front have merged. All right. Anyhow, so now we turn to some really bad weather, like cyclones and hurricanes. All right. So cyclones are areas of low pressure around which the wind will begin to swirl, and that's due to the Coriolis force. Remember, that's a force that occurs just because our planet is spinning, and so in the northern hemisphere, these cyclones will go counterclockwise. In the southern hemisphere, they'll go clockwise. The air converges at the center, which is the area of low pressure, um, and yeah, I mean you can actually, like, if you live anywhere nearby, or if you've ever experienced a tornado going by, even if it's like miles away, you can really feel, if you're outside, you can feel that sudden drop in pressure. It's a pretty amazing thing. Um, yeah, I lived in Indiana for a while. That's where I went to graduate school. And there was a one time when I was up there, and there was a tornado. It was several miles away, but you could literally feel the sudden drop in air pressure. What is the name for a front that occurs when the cold front and warm front merge? Okay, that's what we just talked about, the occluded. Okay, so that's when the two of them merge. Storms are defined as violent, rapid changes in weather. The three major types, of course, are thunderstorms, um, tornadoes, which are cyclones. Well, cyclones, I guess, are both tornadoes and hurricanes. Um, Anyhow, uh, so we'll talk about each. Thunderstorms begin with humid air rising, cooling, and condensing into a single cumulus cloud. Um, it's fed by unstable, moist air. The cumulus cloud grows into what's called a thundercloud, um, and thunderclouds contain a lot of energy. And one of the things that happens with the thunderclouds is, um, the bottom of the cloud will tend to be like, there's charge separation. The bottom of the cloud will be negatively charged. The top of the cloud will tend to be positively charged. But sometimes that the charge at the bottom of the cloud will strike the ground, and of course that's what the thunder is. Or sorry, the lightning is. The thunder is just the air molecules, suddenly expanding, and that's what you hear as the thunder. So lightning heats the air expands, and you hear the thunder. Remember, thunder travels a lot slower. The sound travels a lot slower than light. Light, of course, travels at the speed of light, 3 × 10⁸ meters per second. Just to give you a sense, sound travels around, it's less than, what is it? It's like 744 meters per second. So it's a lot slower. A tornado is a funnel shaped column of air that rotates around a low pressure, and it reaches from a cumulonimbus cloud to the ground. So it's only a tornado if it's actually touching the ground. The funnel cloud can be there, but it's only a tornado when it touches the ground. All right, um, it's just called a funnel cloud if it's not touching the ground. Tornadoes are dangerous because of their the suction and what they do with the high winds. Hurricanes, of course, are the strongest storms on the earth. Very, very, extremely dangerous. I mean, that living in South Carolina,